Hey everyone, welcome back to the Workplace and Apprenticeship 10 videos. In this video, we're going to look at lesson 1 from chapter 6, which is looking at similar polygons. So when two figures are similar, one figure has dimensions, including your length and your width, that are proportional to the other figure. Say if you want an example of something in real life, so a set of toolboxes can be placed inside each other to save space, and therefore would save you in shipping costs when shipping the toolboxes to retailers. So these toolboxes may have dimensions that are proportional, and each box has a length and a width dimensions in the same proportion or ratio as the next larger size. So in order for two figures to be similar, they either A, must be corresponding angles, must be the same size, or B, corresponding sides must be the same proportion. So looking at our, we have this two interesting looking quadrilaterals here. So here it says corresponding angles must be in the same position or same size. So just remember back from previous chapter that corresponding means the same position. So in terms of the same position, say we had this angle right here from side 4 and side 6. Side 8 and side 12 here would be the same position. So these two here would have to have the same size for angle if you were to measure them. And then also the corresponding sides must be the same proportion. So if I were to check this bottom side and create that as a rate, so 6/12, then that same rate we'd have to get for a different side. So say we had 4 and 8. So right now, those two sides right now do not look like they'd be proportional. But if we were to write those as reduced fractions, so divide 6 and 12 by 6 to give us 1/2. Then we could divide our second fraction by 4 to give us 1/2. So they give us the same ratio or same fraction, which makes them proportional. So just to repeat that, so either the corresponding angles must be the exact same size or corresponding sides must be in the same proportion. If one of those are true, then that means that the two figures are similar. And one thing that's really important is that you need to make sure that you check all of your angles. It can't just be one angle makes or works out. You have to check all the angles. So same thing, you have to check the proportion of all the sides to see if they're similar. So you can't just choose one and then call her quits. If we really want to do this fully and really prove that this is a that these two shapes are similar, I'd have to find the proportion of this side on the top right and then this diagonal side here as well. So, but if you were to go and do the math, you'd find that you would get 1/2 or 0.5 for all of those sides. So now we're going to try applying this to a word problem, which is example number 3 from your notes. So Jason wants to build a model of his house. He will build the model using a scale where 5 centimeters represents 2 meters. If one room is 6.5 meters long, 4.8 meters wide, and 2.8 meters tall, what will its dimensions be in the model? So here we're looking for the dimensions of the model, and here we're given a scale. So here we're told that 5 centimeters represents 2 meters. So here you can imagine that this 5 centimeters would go to the model, where that would represent 2 meters in real life. So this here tells us a rate. So or else it also tells us that proportion that our fraction should be equal to. So let's start with looking at the length of our room. And so what we're going to do is we're going to set up our proportions. So here we have 5 centimeters should be equal to 2 centimeters. So that tells us we have 5 centimeters over 2 meters. So that's equal to, so here in real life, we're told that the room is 6.5 meters long. So whenever we're trying to create a proportion, remember we need to have our units on the same place. So if meters is on the bottom in our first fraction, meters has to be in the bottom of our second fraction. So fill this in as 6.5 meters, and then we're looking for the centimeters, so we're going to leave that as x. So now we have two fractions that are equal to one another, which means that we can use cross multiplication to solve. So you'll multiply your first set of numbers. So you have 5 times 6.5, which will give you 32.5. And that's equal to 2 times x. Then we're trying to solve here for x. We're going to divide by 2 on each side. So we find that we would get 16.25 is equal to x. Now while we're at this stage, what you might want to do is fill in your units so you don't forget that in the end. So here in the numerator of our first fraction, we had centimeters here. So that means that our units here will be centimeters as well. So that means that the model will be 16.25 centimeters long. Now we talk about the width of the model. So in real life here, the width of the room was 4.8 meters, and it's still going to be set up, should be equal to this same proportion. So we're going to have 5 centimeters representing 2 meters. So that'll be equal to, here we have 4.8 meters, so that'll go on the bottom. We're going to be looking for those centimeters, so we're going to leave that as x. Once again, we're going to cross multiply and divide in order to solve for our variable, just because we have two fractions that are equal to another. So we have 5 times 4.8, which will give us 24. That's equal to 2 times x, which is just 2x. Then we're trying to solve for x here, so we're going to divide by the number connected with that. So we're going to divide by 2 on each side. And so we'd find that x would be equal to 12. And once again, don't forget to put your units there, just so you don't forget to do it at the end. Then we look at the height, or how tall the room is. And here it states that it is 2.8 meters tall in real life. So let's find out what that is for our model. So we're comparing with that same proportion. So 5 centimeters is equal to 2 meters. And here we're told that it is 2.8 meters tall. So here we can once again cross multiply. So 5 times 2.8 is 14. That's equal to 2 times x, which is just 2x. Then we're going to divide by the number connected with x. So we're going to divide by 2 on each side. And we would find that that height, or that building, is 7 centimeters tall. So one of the more trickier things about this question would be identifying what numbers you're using for your proportion. But then after that, it's the exact same work over and over again, just you're only changing one number at a time. So as you notice, going from each of these different proportions, you're only changing the 6.5 to a 4.8 to a 2.8. So overall, it's the exact same work. So it might seem a little bit tedious, but I think setting up will be probably the toughest part of this question. And then this just goes back to how we learn to solve stuff in chapter 1 of our course. So the last thing that we need to do just to finalize this question is we need to write a concluding sentence. So we can say that the dimensions of the model are 16.25 centimeters long by 12 centimeters wide by 7 centimeters tall. Once you finish that up, you have completely answered the questions, then you guys are ready to move on to your next example. So that is everything here for this video. So thank you guys so much for watching. And if you guys have any questions, make sure to come see me in class or text me on Remind 101.